Okay, so this video is meant for my geometry students. We have a test coming up on Wednesday over chapter 8. This video will cover sections 4 through 7. If you need a refresher on 1 through 3, please refer to the last YouTube video. Alright, so in this first question, we are asked, are the triangles similar? Okay, so I have 4 pictures here. We're going to look at each picture separately. Again, I would suggest you pause, write the problems down, and then try to work at them. Okay, so let's try this first one here. Okay, we're given 2 triangles. In one triangle, we have 2 angles. In the other triangle, we have 1 angle. So let's start with the triangle that we have 2 angles in. I think we can find that third angle. Okay, so if we do 70 plus 67, that'll give us 133. Okay, sorry, 137. I apologize. And then if we take that and subtract it from 180, lo and behold, we get 43 degrees. So this missing angle right here is 43 degrees. And now look at our 2 triangles. One pair of congruent angles. And now we say, okay, you need 2. Angle-angle similarity, right? Let's write that up here. So we have angle similarity, side angle side similarity, or side similarity. Okay, so those are the 3 ways to show if the triangles are similar. Well, we have 1 pair of angles. We need a second pair. E and F, we know nothing about them. All we know is that, together with 43, they add up to 180. But they could be, relatively, many combinations. So we don't know enough information. So right here, this first problem, we're going to say they are not similar. Okay. All right. Let's move down to this problem right here. I'm sorry. Yeah, let's move down. Okay, so here we go. 2 triangles. Triangles are embedded in one another, right? You see the big triangle here, L and P, the smaller triangle here, M and O. I see 1 pair of congruent angles. That's good. Well, these angles are special. These are corresponding angles. And we are told that they are congruent, so therefore we know that a couple lines are parallel. We know that those lines are parallel. Okay? All right, so that's enough. That's something there. So we can use the fact that these lines are parallel to say that the other corresponding angles are congruent. Okay? We could also have said that angle N is congruent to itself because it's used in both triangles. This would be like a reflexive property idea. Angle N is angle N is angle N. Okay, so it's congruent to itself. But here we go. Angle similarity tells me that these 2 triangles are similar. So let's start in the big one. Triangle LPN. 1 marking, 2 markings, 3 markings is similar. LPN is similar to triangle MON. Triangle MON. Yes, MON. And there we go. Okay, I'm going to slide my board over here, and now we have these 2 pictures left. Let's look at the top one first. Okay, we have 2 triangles. Notice that we have 1 pair of angles congruent. Okay, and then they give us 2 sides here. Well, let's focus on maybe side angle side similarity, because notice where the angle is. It's in between the sides. Well, we know that the angles are congruent. Now, are the sides proportional? Well, let's start here. 3 corresponds to 5 in this triangle. Is that equal to, let's go back to the smaller triangle, 6 over its corresponding side, which is 8. So remember, there's 2 ways to do this. You can either simplify them, right, or plug them in the calculator, or you can cross multiply. If the cross products are the same, then the proportion is equal. I'm going to simplify them. 3 divided by 5 is 0.6. 6 divided by 8 is 0.75. They're not equal. Since they are not equal, the sides are not proportional. These figures are not similar. Okay, so side angle side. 2 sides and the angle between. The 2 sides have to be proportional. Angle between are congruent. Okay, now let's take a look at these 2 triangles down here. Okay, notice that within each triangle there's some congruent markings. So in this triangle we have IJ congruent to JK. So if IJ is 5, JK is also 5. Up here, GH is 4. That means FH is also 4, congruent. And now let's try to use side similarity. Okay, we really only need to compare two sides because these ones are congruent, but we'll do them all. 5 corresponds to 4. Is that going to be equal to 5 corresponding to the other 4? Is that going to be equal to 10 corresponding to 8? Okay, well, if you simplify all of these, you get 1.25, 1.25, and 10 divided by 8, lo and behold, is 1.25. They are all equal, so by side, side, side similarity, we can say that these two triangles, and you have options because of the two congruent sides. So I'll just go alphabetical order. Triangle FGH is similar to triangle, so FGH. Let's go with KJI. KJI. You just got to make sure that FH and IK, FH is first and last, IK is first and last, that they correspond. And there we go. So there's showing two triangles similar. Okay, so we're going to take a look at this problem here where we have to use the figure on the right to fill in each proportion. Okay, so remember we're using similar triangles here and the triangle proportionality theorem here as well. All right, so AB over AF. So AB is this side over AF. So we're strictly on the sides. Is going to be equal to, okay, so BC, so we're using one of the parallel sides. Well, AB comes from this smaller triangle, AB. So does BC. AF is the bigger triangle, so we must use the corresponding side to BC from the big triangle. That's going to be FG. Okay. So we used, again, we used AB over AF, so small triangle, big triangle, is equal to BC small triangle over FG big triangle. Number 2, and I guess what I can do is I can, I'm not going to use the different colors. We'll just have to talk about it. All right, number 2, BD, this short side, over DF. Okay, so we're using the triangle proportionality theorem here. BD over DF is equal to blank over EG. Well, that's this side right here, CE. Number 3, AD, okay, so the medium triangle, over BD, this short side right here, is equal to AE, the medium triangle, over this short side right here, CE. Number 4, AC, short triangle, AG, big triangle, over AB, short triangle, over big triangle, AF. Number 5, DE. Okay, DE is a parallel side, so we're using similar triangles. DE is the medium triangle over FG. FG is from the big triangle, so medium triangle over the big triangle is equal to AD, medium triangle over the big triangle, AF. So notice in this one, they didn't stay within, what I want to say is they did not stay within the triangle. They went from the medium triangle to the large triangle, so you have to go from the medium triangle to the large triangle. Okay, similar triangles. And then number 6, AB, small triangle, over DF, this little side right here. So we're using the triangle proportionality theorem, or the parallel lines theorem, whichever one you want to use. But AB is this short side, DF is that short side, so we got to go to the other side. Blank over EG. Well, AB is here, DF is here. EG's down here, went across from DF, so we need to go across from AB. That would be AC. And there are the proportions filled in with either the similar triangles idea, the triangle proportionality theorem, or the parallel lines idea as well. Okay, here's our new 2 problems. In these problems, we need to find x. All right. So in the first problem here, we're dealing with an angle bisector. Okay. Notice that these 2 angles are congruent. That means XW bisected angle x. So this is my angle bisector. So remember, when you're setting up a proportion, stay above the angle bisector, then stay below. So I want to find x. So x over 6 equals, now I'm missing this. I need this part right here. Okay, I don't know what that is. Well, the whole thing is 5. This part's x. Why don't we just call that 5 minus x? 5 minus x over 9. And there's our proportion in which we cross multiply. So go 9x equals 6 times 5 minus x. I'll distribute 9x equals 30 minus 6x. I will add 6x to both sides to get 15x equals 30, and then divide by 15. Okay, so we have 15x equals 30. Divide by 15 to get that x all by itself. X is 2. Okay, so don't get tricked up by this. All right, if you have 2 of the 3, you can always write an expression for the third one. Okay, over here, now we have the parallel lines. So now we're going to use the triangle proportionality theorem. Okay, so let's start at the tip. This is my tip. Let's go x over 5. X over 5, so we did the high side. Now go back to the tip. Equals 16 over 4. We're going to cross multiply. 4x equals 80. And divide by 4. X equals 20. Triangle proportionality theorem. Okay, so here are 2 new problems here. Okay, so number 4. Identify the dilation and scale factor. Then find x and y. Okay, there's a z here. We're not going to worry about this z. Okay, so find x and y. All right, so in each of these problems, first thing, you're going from P, the preimage, to P prime. So P is in this triangle here. P prime is in this triangle here. We are going from small to big, so my scale factor is greater than 1. So here, the scale factor is going to be, now we have a pair of corresponding sides here and here. 9 over 4. Greater than 1, and it does not simplify. If you are going from small to big, you are considered an enlargement. Or enlarge, whichever you want to prefer. I don't care. Okay? And now find x and y. X and y are in the new image. Okay? The image. So to find x, we take its corresponding side. X corresponds with 3. We take 3 and multiply it by the 9/4 to get 27 over 4. And there's our value of x. Y is here, the bottom side. It corresponds with this 6. So we take y, its corresponding side, and we multiply by 9/4. Now we're going to get 54 over 4, but that simplifies. 54 over 4, both divided by 2 to get 27 over 2. Okay, and there is x and y. Okay. Now over here, okay, so again, identify what's happening from P to P prime. From P to P prime, P is in this big figure, P prime is in the smaller one. We're going big to small. That means your scale factor is less than 1, and you are a reduction. Or reduce, whatever you want to put. Okay? Scale factor here. Let's find the pair of corresponding sides. The pair of corresponding sides is 13.5 and 9. We want to be less than 1. Okay, so small number on top. And now again, if you remember in class, there's a decimal. Move that decimal 1 place to the right. So move that decimal 1 place to the right. And it becomes 90 over 135. And we simplify this. Okay, 90 over 135. I believe I can divide both by 9 to get 10 over 15, and that keeps going. Divide by 5. So my scale factor comes out to be 2 over 3. Okay, so again, you're going from big to small, reducing. Now, this one's a tricky one, and I'm glad you're watching this video. Look where x is. X is in the pre-image. Okay, so we are not going to do what the scale factor says because we need to go backwards. We need to go backwards. X is here. 5 is what it corresponds to, but we're going backwards. So instead of multiplying by 2/3, we're going to multiply by the reciprocal. because again we are going backwards. So originally x was 15 halves originally, but then after the scale factor took place, it went to 5. You could also put 15 halves as also 7.5. I also want to do that over here. Sorry to jump back to this problem, but if you divide 27 and 4, you will get 6.75, which is good enough. And 27 divided by 2, you will get 13.5, which is also good enough. Okay. Now let me slide down just a sec to find y. So again, because x and y are in the pre-image, we are going backwards. We're going backwards to find y, backwards to find x. So we don't do what the scale factor says. We take the resulting corresponding side 7 and we do the opposite of the scale factor. Multiplying by 2/3, the opposite would be multiplied by 3 halves. And we get 21 over 2, which is 10.5. So be aware of that. But again, scale factor, remember, if you want to change your side lengths, just take those side lengths and multiply them by the scale factor. Okay? And again, notice that x and y are bigger than their corresponding sides because they're in the bigger figure. So that's a very good problem. I'm glad you got to see that problem. Okay, so here's the last problem. We're going to use the coordinate plane to show the dilation. Okay, so we have this four-sided figure, GHIJ. We're going to use a scale factor of 1/2 to dilate the figure. Okay, so with a scale factor of 1/2, remember, you're going to get smaller. Okay, so this is a reduction. Let me use a different color to show this. This is a reduction. Now what I'll do is on this figure, and I'll use red, I'm going to list the regular coordinates. So G's coordinates are -2, 2. H's are 0, 1, 2, 3, 4, 5, 6. I's are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 8, 5. And J is 1, 2, 3, 4, 5, 6, 1. So now what I'm going to do is, if you remember, if you have the point xy to incorporate a scale factor dilation, you just take kx, ky, where this scale factor is your k value. Okay? So I'm going to use orange here, but then blue on the picture. So we need to find g prime, h prime, I prime, and j prime. Well, g's coordinates are -2, 2. We're going to multiply by 1/2. Just take half of it, -1, 1. H is 0, 6. Just take half of its coordinates, 0, 3. I is 8, 5. Take half of the coordinates, 4. And then half of 5 is 2.5. And then J, its coordinates are 6, 1. Take half of 6, 1. That's 3. And then a half as the y coordinate. So now in blue, I'm going to graph G prime, H prime, I prime, J prime. Okay, so these are the new coordinates. G prime -1, 1. H prime 0, 3. I prime 4, 2 and a half. And J prime 3 and then 1/2. And what we should see is we should see a dilated figure of the original. Okay, and notice smaller, half the size, half the size. One thing that you can look at is if, and how about I use purple. If the origin is your center, then if you connect the origin through G prime and G, it's a straight line. Same thing with all the other points. The origin to H prime and H, you'll get a straight line. And that's a way that you can check your figure. Okay, but again, this is all you have to do. Take your coordinates and multiply them by the scale factor. Okay, so hopefully this video helped you prepare for your test on Wednesday. If you need to watch the other video, I would highly recommend it. All right, see you Wednesday.